So, good evening, everyone, and this is lecture number 5, JEE Advanced. And today, as promised, we will be starting and finishing off electric current, right? Now, first of all, tell me what type of problems we have to discuss today in circuits. What sort of problems you have? What types of question you think that you are not good at, or you want more practice? Questions on circuits?
Questions, sir.
Questions on what? Circuits?
Yes, sir.
Okay. Let me start with the first very basic one. If you ever get a question like this, and this is the most general form of circuit that you will get, and just make it general. This is E1, this is E2, this is R1, this is R2, and this is, let us say, R3. And if I ask you what is the current in each branch, how do you solve a question of this nature? That is my first question.
Shall potential at junction one.
Sorry, I'm not able to hear you. Can you speak a bit loud?
Potential at one junction is 0 and another junction is V. Now
Potential of one junction is 0. So this potential, I take it as 0.
And the another is V.
And I take the potential of this junction as V. Then how do you do it?
V minus E2 by R plus sum of the
Your voice is breaking a bit, huh?
sum of the currents is 0.
Okay. So if I say one current goes here, one current goes here, one current goes here, the sum of the current is 0. Okay. Then what equation do you get from there?
So V minus
Your voice is breaking up.
V minus E2 by R2 plus V minus E1 by R1 plus V by R3 equal to 0.
Okay. V minus E1 by R1 plus V minus E2 by R2 plus V divided by R3 is equal to 0. Well done. This is what we call as the Nodal theorem. Do we know this?
So
Okay. Now what happens if I just change this question and I make it, for example, like this? So I put it like this. I can make a number of branches like this. Let me call this as E. Let me call this as E1. This is R1. This is E2. This is R2. This is E3 and this is R3. Then how will you do it? I'll give you a minute. I'll give you a minute to think about it, okay? Think about it and tell me how to do it.
take initial.
At any corner, take 0 as potential, okay? So let me take this point as 0. Then how will you do it? You're right. You're correct. Going in the right direction.
Z E minus 0. Next has also 0.
Yeah. Everything is 0. I understood that. This is also 0. This is also 0. I understood that.
Right.
How do I get the currents?
E3 by R3 plus. Okay.
If I call this current as I, if I call this current as I1, if I call this current as I2, this current as I3, this current as I4, this current as I5. What will the value of I1, I2, I3, I4, I5, and I? You want time to think about it?
Yes, sir.
I'll give you 2 minutes. Think about it. It's a very simple question. Well, don't worry. It is quite simple. Now see, you actually gave half of the answer. In fact, the full of the answer was given by you. You basically got trapped because you could not understand what is going to happen with this branch because there is no resistance in this branch. Yes or no?
Yes, sir.
As soon as you told me that you were using Nodal, I was very surprised that you know how to do it. But I know that you will get trapped if you have not done this question. In fact, this is very simple. So you see how it is simple. You call all these points as zero, yeah, right? If this point is zero, then this point or this point or this point become equal to E. Yes or no?
Yes, sir.
Because this is zero. If I go along this path from O to this point, I will get 0 plus E will be the potential of the highest point. So all these points have the potential E. Yes or no?
Yes, sir.
Now, once you understand that the potential of these points are E and these points are 0, you can easily calculate the current in this branch, the current in this branch, and the current in this branch. Yes or no?
Yes, sir.
Tell me what is the current in this branch, I1.
E minus E1 by R1.
E minus E1 by R1. Very good. What is the current in the branch R2?
E minus E2 by R2.
E minus E2 by R2. On similar lines, the current in the third branch would be E minus E3 by R3. Yes or no?
Yes, sir.
Now, if you look at the value of this I4 and I3 are same. Yes or no?
0. 0, sir.
I4 and I3 are same, right?
Yes, sir.
So I4 and I3 are same. Now, if you look at this junction, I5 will be equal to I4 plus I2. Yes or no?
Yes, sir.
If you look at this junction, all the currents are outgoing. So I plus I1 plus I5 will be equal to 0. Yes or no?
Yes, sir.
So your entire circuit is solved and you get the answers for all the branches. Did you get me?
Yes, sir.
Did you understand how I've used the same nodal theorem
Yes,
and
sir.
used it in a more convenient way? Got it? Let us now move on to more questions. Let us first try and deal with questions on circuits because that is where you would be lagging. Yes or no?
Yes, sir.
So let us move on to those questions where we have circuits coming into the picture, and then we will move on to questions where which are a bit different. Let me see where the question is. The questions on shunt. See where the question is. Okay, here are some interesting ones. Let us start with this one. Probably a more difficult one, but I would be very happy if you can do this. This question has 3 or 4 parts. Let us see if you can do any of this. This is from your sheet only. In a given resistor, 7 resistances are connected like this. Each resistance is 2 ohms, and you have 6 batteries of 2 volt each are joined together. The first question is, what is the potential difference between D, this point, and E, this point. The second question is what is the current through the branch BG? There is one more or two more points. But if you solve this circuit, the rest of the points will definitely come. So let us now focus on these two questions. I'll give you 2 minutes to solve this. Great. If you got the answer, let me check if this answer is correct. The first answer is 6 by 5. And the
Yes,
second
sir.
answer is
0.4.
0.6. Okay. Tell me, how did you do this? How did you do this? How did you do this, beta? Is this the way you did it?
Yes, sir.
Okay. You call branch current in this branch, current in this branch, and current in this branch would be same. This branch would be same. This branch would be same because the potential difference is same. They have done it in a different way. This is I1, this is I2, this is I3, this is I4, this is I5, this is I6, and this is I7. I1 plus I2 plus I3 plus I4 plus I5 plus I6 plus I is equal to I7. You just put the values of each and everything and you get the answer for the first part. Yes or no?
Yes, sir.
To do the second part, once you get the answer for the first part, the second part is pretty simple because you just have to, once you get the value of x, you can subtract the value of x from 0. I mean, that will be x minus 0 divided by r, that is the resistance, will be the current. Yes or no?
Yes, sir.
The third part of the question was current to the battery AB. So current to the battery AB, that is the third part of the question. I'll show you the question again. The question is here. What is the current to the battery AB? This one.
Six by 7.
Yes, beta?
6 by 7.
6 by 7. And the answer is still what I see is 0.6. If you look at this branch, and here is this branch, and if you look at the distribution of potentials, if you look at this point A and you look at this point B, the potential difference is is how much? So you go from A to B and you see how much is the potential difference. And oh, sorry, we'll not get it from here. You go from this point A to this point and you look at the potential difference between this point and you divide it by the resistance, which is 2 ohms. This is how you will get the current in this branch. Did you get my point, bacha?
Yes, sir.
So the answer is still zero point 0.6. Nothing has changed. Do we understand this?
Yes, sir.
Correct?
Yes, sir.
Shall I move to the next question, beta?
Hmm.
Right? You got this question?
Yes, sir.
Okay. Let us move on to this one, an
Seat
enterprising one.
seat send किया sir.
Yes, beta?
Seat send किया.
क्या बोला बेटा?
Seat send किया ना sir. PDF.
Yes, yes, I have sent you yesterday only. You did not get it?
Yes, sir. Not get it.
I sent you the sheet yesterday only, the same time. Okay, I'll check it again. Meanwhile, you try this question. This again is a comprehension type, and you have various questions. The network resistance is constructed with R1 and R2. I showed in the figure. The potential of point 1, 2, 3 up till N are V1, V2, V3, Vn. Each having potential K times smaller than the previous one. What is the ratio of R1 by R2? This is the first question. I'll give you time to do this. Well, I'll check whether the sheet has been received or not. I've sent the sheet, beta. Check it out with the office people there, okay? The sheet is there. Don't worry. Give you time to solve this. Remember, it's a simple question. Why I started with these questions? Because I thought that these are the questions that you can easily do. It might look tough. But remember, the first thing that I asked you, the first question that you solved, everything is based on that. Trust me. First question, if you can do the first one, then the other two one would be rather simple. I'll give you time, don't worry.
Option A, k square minus 1 by.
Yes, beta, you got the answer?
Option A I got.
Which one you got?
K square minus 1 by k.
No, that is not the answer, I think. To find the value of R1 by R2.
Option C. Option C, sir.
Shall you, do you want me to solve it for you?
Yes, sir.
Okay. Now I'll solve one part and I hope that after this you would be able to do the other ones. Okay. See, it's very simple. Do you see this current I? Do you see this current I1? And do you see this current I2? Yes or no? So
Yes,
your
sir.
I will be equal to I1 plus I2. Yes or no?
Yes, sir.
That's it. Now look at V1. This V1 is V0 by K. V2 is V1 by K. And V3 is V2 by K, and so on. You put the values here. You solve for the value of R1 and R2, and you get this answer, K minus 1 the whole square divided by K. You must have done some
It's a
mistake. I
constant.
hope you were thinking on same lines. Yes or no?
Sir, explain, sir, once.
You see this current? Oops. You see this current I? This current I, this current I1 and this current I2. I will be equal to I1 plus I2. I've applied junction law at this point. Yes or no? Do you understand this? Now, the potential of this is V0. The potential of this point is V1. So V0 minus V1 becomes your I1, becomes your I. Yes or no?
Yes, sir.
Similarly, your I1 becomes V1 minus V2 divided by R1. Yes or no?
Yes, sir.
Similarly, your I2, this is grounded. It becomes V1 minus 0 divided by R2. And I is equal to I1 plus I2, and you get your answers. V1 is V0 by K, and V2 is V1 by K. You have to be careful with the calculations. Did you get the answer better now?
Yes, sir. Understood.
Bakka?
Pakka.
No doubts now?
No doubt, sir.
Will you be able to solve? Oops, sorry. You were not able to see the screen. Sorry. Now you can see the screen? Sorry. So this is your V0, this is your V1, and this is your V2. Sorry. This is your current I, this is your current I1, and this is your current I2. Got this point, beta? I did not know that you were not able to see the screen. So I'm sorry for that. Do you get it now, beta?
Yes, sir.
Now, if you got this, can you do the other two questions that will tell me that you have understood? And the other two questions are pretty damn simple. What is the ratio of R2 and R3? And what is the current passing through the register R2, which is nearest to V0? Nearest to V0 means the register R2 which is connected to V1. They want to find the current in that branch. I think you can do that. They also want to find us to find out the ratio of R2 by R3. Can you do R2 by R3 for me? R2 by R3. R3 is the last register. Do we understand this?
Yes, sir.
R3 is the last register. This one. Ratio of R2 by R3. Can you do this?
Yes.
Yes or no? No, yes.
Yes, sir. Wait.
I'll give you time. Remember, R3 is the last resistor.
K square minus 1 by K.
How much, beta?
K square minus 1 by K.
The answer, I think, is K upon 1, K minus 1. Did you get this? K upon K minus 1.
No, sir. That is not that.
Okay. You missed 1 point, I think. Remember, all of these questions are based on very, very simple concepts, and we should not forget this. See, if I call this current as I1 and if I call this current as I2, I1 shall be equal to I2. Yes or no?
Yes, sir.
To get the value of I1, I will subtract Vn. This is Vn. Vn minus 1. Vn minus 1 minus Vn divided by R1. This would be the value of I1. Yes or no? And that would be equal to I2, which is Vn minus 0 divided by R3. Are you getting my point, bacha? Yes or no?
Yes, sir.
You already know R1 by R2. Now you know R1 by R3. You should be able to calculate R2 by R3. Yes or no? No, yes. You can have a look at the solution also. The current in both the branches would be same. This is the first current, this is the second current. They both would be same. So R1 becomes R3 into K minus 1. You already know the value of R1 or you know the value of R1 in terms of R2. From there you will get R2 in terms of R3. Do we understand this?
Yes, sir.
Any doubts, please ask.
No, sir. Understood.
Then I think this is the easiest one. The current which passes through the resistance R2, which is closest to V0. I'll give you a minute to do this. बनी आया क्या वो?
Option A. K minus 1 whole square by K. V0 by R3. Option A, sir.
Hello, Amita, you got it?
K minus 1 whole square by K V naught by R3.
Okay, I think your answer matches one of the options. So I think that should be correct. It was pretty simple, right?
Yes, sir.
Yeah, so once you understand the question, it was pretty simple. And I hope that you have done the same thing. Yes or no?
Yes, sir.
Okay, so let us move on to a question of this nature. It's a question based on galvanometer and ammeter. The diagram is not given. I hope you can do this. An ammeter and a voltmeter are connected in series to a battery with an EMF of 10 volts. When a certain resistance is connected in parallel with the voltmeter, the reading of the voltmeter decreases 3 times, whereas the reading of the ammeter increases 2 times. Find the voltmeter reading after the connection of the resistance. If the resistance of the ammeter is 2 ohms, what is the resistance of the voltmeter? There is one more question which we'll deal once we are done with these two. There's no diagram given. This is what is given. I hope you can do this. Best of luck. Have you seen a question of this nature before?
Sir?
Have you solved a question like this before?
Not yet, sir.
Okay.
We'll try it, sir.
This is the time that you'll do it. 2 minutes. The good thing is, the whatever resistance is connected is not given. So very less data. That means it's a straightforward question. Yes or no? Might
Yes,
look
sir.
confusing. It might look confusing. Remember, this is how, and I keep on repeating, this is how questions are framed in a JEE that you get caught. But I guess you will not. 2 minutes.
Sir, 4 volt. Sir.
Yes, bacha.
4.
4 volt is what? The final reading in the voltmeter, 4 volt.
Yes, sir.
It's 2 volt.
2 volt.
Do you want me to solve it or will you try
Sir,
again?
I will try again, sir.
Please try it again. I am pretty sure that you would get the answer, beta. I want you to do it and understand how simple this is. I hope you have drawn the diagram.
Yes, sir.
Please do it. I know you can do this. Have faith. I want you to do this. Else I'll solve it. Don't worry.
सर एक बार दिखाओ सर नहीं आ रहा 2 वोल्ट
नहीं आ रहा too.
2 नहीं आ रहा सर मुझे
Okay, don't worry. आएगा आएगा. It will come. It will come. And as soon as you see this diagram, it will start to make sense. And here comes the diagram. See, it's pretty simple.
yes sir same I did
Same you did.
हाँ
This is V1 and this is V2. First case, and V1 plus V2 is 10 volts. Yes or no?
yes sir
In
yeah
second case, this is V1 by 3 and this is 2V2. Current becomes twice, so potential difference across the
yes sir then
meter
yes, sir.
becomes twice.
Calculation mistake sir okay sir
Calculation
same
mistake. Okay, so you got the second.
sir
You got the answer as 2 volts. Well done, bacha.
yes sir
Now let us bring our attention to the other two questions. There were three questions here. So now we will look at all the three. First of this is solved. Let us look at the other two. And the other two are like this. If the resistance of the emitter is now given, what is the resistance of the voltmeter? That is question number 2. If the resistance of the emitter is 2 ohm, then the resistance of the resistor which is added in parallel to the voltmeter is how much? So basically, now you know the resistance of the emitter and you have to find the other two resistances. The other two resistances are the resistance of the voltmeter and the resistance of the resistor that is connected in parallel with the voltmeter. Do we understand this?
yes sir
Your time starts now.
4 resistance of 1 meter to connected 1 meter is 2 ohm resistance of the each added to the meter सर 4 23rd का 4 आंसर 24 का 2/7
23rd ka your answer, the resistance of the voltmeter is coming as 4 ohms. And 24th ka
2/7
the correct answer is this. We already know the value of V1 and V2. V1 and V2 will be inversely proportional. Yes or no? Current is same. Or directly proportional, right?
yes sir
So resistance of the emitter is 2. Resistance of the voltmeter will come as 3. Yes or no? Current is same.
yes sir
Got it? Then when the voltmeter is connected
3/5
with a parallel resistor, we can find the effective resistance of the voltmeter and take the ratio with the resistance of the emitter. Now the voltages are V1 by 3 and twice V2. From there you will get the resistance
Yes
of
sir,
the
yes sir.
parallel shunt resistance. Do we understand this?
यस सर, मैंने ऐसा नहीं किया सर, दूसरा तरफ से किया इसलिए नहीं
You
आया.
did the same thing, bacha?
No sir, I did different way, so I got wrong answer.
But you have understood what is the correct way?
Yes sir.
Okay. You should have got this sheet. This is a really good sheet. Really good questions, right?
Yes sir.
Anyways, these are the type of questions that you will find in the examination hall, and this is a circuit diagram that you might have to draw, but don't have the sheet because it's a match the column type problem. Okay. Will you be able to draw this diagram quickly?
Yes, I will draw sir, just wait.
Okay. Okay. Draw it. Draw it. I'll give you time.
Yes sir.
Okay.
Done sir.
I'll just, since you have drawn the diagram, now I would show you the questions. So these questions are based on the cells that we have seen, and the questions are like this. To match the column, remember it's a multiple type match the column. You understand the meaning of multiple type match the column?
Yes sir.
One entry here can match with more than one entry on the right hand side. Similarly, one entry on the left hand side, right hand side can match with more than one entry on the left hand side. Cell number 1, cell number 2, 3, 4. Chemical energy is decreasing, increasing. Work done
सर
by
ये
the cell
सब
is
सारा
positive.
एडवांस क्वेश्चन है ना सर?
Yes, beta.
ये सारा एडवांस क्वेश्चन है ना सर?
Right, sir.
Oh,
All these are advanced question. Don't worry.
okay sir.
So it's basically want to check whether you understand the concept of work done by the battery, on the battery,
Yes
and
sir.
so on. So basically, you will have to solve the circuit to get anywhere near getting the answer. Do you understand this? So the
Yes
question
sir.
might not have numerical answers, but the answer will only come once you solve the numerical part. Got it? Give you 2 minutes to do this. I hope you have drawn the diagram.
Sir, once diagram.
Okay, what I'll do is I'll try to squeeze everything in. The only thing is, in that case, the font will become smaller, but let
No
me try to
problem sir. We
squeeze
can.
everything in. I hope the screen is big enough
Yes
for
sir.
you to see, right? You can see the entire question now?
Yes sir, I can see clearly.
Okay, great. So you have your entire question on the screen and you have the different match the column as well. Your time begins now. Do you need any help, Acha?
With just it's doing. So AQ,
Okay, AQ,
BR,
BR,
CP,
CP,
DS.
DS. Well, the correct answers are like this. Remember, it's a multiple matching type. Do we understand this is a multiple matching type?
Yes, sir. Yes, sir.
So first of all, what you got to do is solve the circuit here. I think that would be simple. Did you get the same answers as like this? They've taken this as I1, they've taken this as I2, and they've taken this as I3. Did you get the same answer? Did you did you solve for the current? Yes or no?
Yes, sir.
Did you get the same answers? The direction will not. Yes or no?
Yes, sir.
Okay.
Sir, squeeze करो sir. वो भी
I1
दिखा रहा.
I1 is like this. It is 2 by 33. Did you get it?
Yes, sir.
Okay. I2 is in the same direction and it is 14 by 33. And I3 is in the opposite direction. It is like this and it is 12 by 33. Now you can see which battery is getting discharged, which battery is getting charged. Remember, when battery is getting discharged, chemical energy is decreasing, work is done by the battery. Yes or no? Which battery is getting charged and which battery is getting discharged? If the current is flowing from the positive to the negative outside the battery, it is getting discharged. Yes or no?
Yes, sir. Positive negative discharge.
So this battery is
Negative.
getting charged. Yes or no?
Yes, sir.
Okay. These two batteries, both of these two batteries, they are getting discharged.
Discharge.
Yes or no?
Yes, sir.
And this battery is
Thermal
getting
charging.
charged. Yes or no?
Yes, sir.
That's it. That will give you your answers. Yes or no?
Yes, sir.
So, looking at what we had discussed, and let me decrease the size of this thing. And this is the explanation of the answer. In each cell, thermal energy will be dissipated due to internal resistance, whether the chemical energy of the cell is increasing or decreasing. Cell 1 is getting charged, chemical energy increases. Yes or no? Cell 2 and 3 both are getting discharged, it's decreasing. So work done by them is positive. Cell 4 is getting charged, its chemical energy increases.
Yes.
And then you can match with their options. Yes or no?
Yes,
Now,
sir.
one option is S, which is thermal energy developed in all the cell is positive because current is flowing and they have got internal resistance. So there will always be thermal energy developed in all of the cells and which will be positive. Yes or no?
Yes, sir.
So S will come in all the four options. A, B, C, and D. Yes or no?
Yes, sir. Yes, sir.
Yes or no, bacha?
Yes, sir.
So that would be the answer. Did you get this, beta?
Yes, sir. Got
Please
it.
ask the office people, they'll give you this sheet, and I hope that you can solve the rest of the question of this sheet, and we will discuss them in the next class. Okay, don't worry.
Okay. Okay, sir.
This one question will come from electric current or capacitors. This one, in a given circuit, the voltmeter and the electric cell are all ideal. Find the reading of the voltmeter. Oh. Voltmeter is ideal. What do you mean by an ideal voltmeter? Hmm? What do you mean by an ideal voltmeter, Bacha? It has infinite resistance. Do we get this?
Yes, sir. Infinite resistor.
Ideal emitter is a emitter which has zero resistance. So basically, they are saying the resistance of the voltmeter is zero. What is the reading of the voltmeter? This is a simpler one. Integer type question. I wait for your answer. Remember, integer type are always simpler than match the following or multiple choice. Can I expect an answer on this one?
सर टाइम दियो सर करेगा.
I'm waiting patiently for your answers.
Okay, sir.
It should not take so long, beta. I can't wait anymore. What happens if this gentleman has infinite resistance, beta?
1 volt, sir.
Yes, okay. Thank God. So no current will flow in this branch. It is out of this circuit. Yes or no? You
Yes, sir.
basically have to find out the potential difference between these 2 points. Battery is 2 volt. Resistance is 2 ohms. Current is 1 ampere. You multiply it by 1. The answer would be 1. Yes or no?
Yes, sir.
Straightforward question. Now a question based on this. I hope you know this. If you don't know this, I'll tell you this. First read the question and tell me whether you know it or not. This is this. A
Which
battery of
one
internal
does?
resistance 4 ohm is connected to a network of resistance. In order that the maximum power delivered to the circuit, what is the value of R? Do you know maximum power delivered? Do you know maximum power delivered?
Yes, sir.
It is known as maximum power
Maximum power of
transfer
air.
theorem. Do you know this? Yes or no?
Yes, sir.
What is that maximum power transfer theorem?
When internal resistance is equal to R.
Okay, then you have this question waiting for you.
Twenty-four by 5.
That is absolutely wrong.
Sir, equivalence resistance is equal to internal resistance, na, sir?
Yes, na sir. This is a balanced Wheatstone bridge, na sir. Do you understand that, sir? So this resistance goes away, bacha. This is 2R. This is 4R. This is R. This is 2R. Balanced Wheatstone bridge. R and 2R are in series. 3R. 2R and 4R are in series. 6R. 3R and 6R are in parallel. 2R. 2R should be equal to 4. So R is equal to 2. Is it so difficult to calculate? Difficult to calculate?
Yes, sir.
Do you understand what I've said?
Yes, sir.
I shall give you one more question on this, and for that question, I'll have to take you to my sheet. And here comes, oops. Here comes my sheet. So now you'll have to do this. I hope you can see this, my sheet. Yes or no?
Yes, sir.
Okay. So the question goes like this. I want maximum power to be delivered to this register. What is the value of this register? And what is the maximum power developed? You understand the question? The highlighted register should have maximum power delivered to it. What should be the value of that R? Have you done a question like this before? Yes or no?
Yes, sir.
Your chance to do it again. Uh, one thing I should tell you is the value of this E. I should not write it as E because I want numerical answers. So let me put this as 10 volt. 10 volt की battery. Time starts now. Do you need any help?
Sir, wait, sir. Will.
You can see the screen now, right?
Yes, sir. Sir, 12.
The value of the register is 12. How did you get it?
The value of R is equal to 6, sir.
The value of R is?
6.
How did you get 6?
Equivalence resistance is equals to 4, na, sir.
Yes, beta.
Equivalence resistance is equals to 4, na, sir.
What equivalent register?
Whole equivalent resistance is equals to 4.
What do you mean by whole equivalent resistance?
Means the 4 ohms is in inter.
4 ohms is the internal resistance. Okay, I got it. So
R and 3 ohms are in parallel because they are connected same potential.
okay, so
And 2 ohms is series in with that.
okay, so
The equivalence resistance is equals to 4, na, sir.
no, this is now how it is done. That is why I asked, have you solved a question like this before? Okay. Let me not waste any more time and tell you how to solve this. Okay, now whenever this question comes, what we do is we convert it into what we call it as the Thevenin's equivalent diagram. Have you heard this term? Have you heard this term before?
Sir?
Thevenin's equivalent diagram. Have you heard this term before?
No, sir.
So what we will do is once we have this diagram in this form, if I call this as R and if I call this as R and if I call this as E, now once this circuit, which is on the black side, becomes a circuit on the red side, then I can say that this capital R will be equal to small r. Yes or no?
Yes, sir.
This small r is known as R Thevenin. What it is known as? Thevenin. Thevenin equivalent resistance. What do you know? Call it?
Thevenin.
Thevenin equivalent resistance. Now, how do I get this? R Thevenin is this. What I do is I find the equivalent resistance across these 2 points. I assume that this resistance R is taken out of the circuit. This resistance R is taken out of the circuit, is gone. And then I find the equivalent resistance between point A and B. Do you get this?
Yes, sir.
Now, this battery is also shorted. So whenever you find this Thevenin equivalent resistance, battery is shorted. And this is how you find the value of R Thevenin. Do we understand this? Now you find the equivalent resistance between A and B. What is the equivalent resistance between points A and B? Points A and B come here, basically.
20/9.
No. 2 and 4 are in series. That is 6. 6 and 3 are in parallel. So this equivalent Thevenin resistance becomes parallel of 6 and 3, which is 2 ohms. Do we understand this, bacha?
Yes, sir.
So R Thevenin is 2 ohms. Therefore, this resistance would be 2 ohms. Do we understand this, bacha?
Yes, sir.
So the value of this resistance is 2 ohms. This is the normal question that you will get in your JEE. Now, what they can also ask you is what is the power dissipated in that? Now, if the question is like this,
V square by
it
R.
is converted into this form. So the current in the circuit is E square by 2 times small r or 2 times R. So current square is this multiplied by square multiplied by r. So your basically answer will be e square divided by
2.
4r. Yes or no?
Yes, sir.
But you have to find the value of this e. Now, how do I get the value of this e? The value of this e is the potential drop across these 2 points when
I into R.
register is taken out and I have to reconnect the battery here. Do we understand this? This
Yes,
is
sir.
known as the Thevenin's equivalent diagram. Are you getting my point, bacha?
Sir. Yes, sir.
So basically what I will do now is I will find the value of this E. To get the value of this E is very simple because I have simple current flowing in one circuit. The current which will be flowing in this circuit which will be going like this. This current I will be equal to 10 divided by 9 ohms. Yes or no, bacha?
Yes, sir.
Not 10 divided by 9 ampere. Yes or no?
Yes, sir.
To get the value of this E, this will be simply equal to this resistor multiplied by this current. Yes or no?
Yes, sir.
So this will be equal to 10 by 3 volts. Yes or no?
Yes, sir.
So this will be equal to 10 by 3 volt. Now you can put this value in this equation and you will get the maximum power which is getting dissipated in this battery. This is how you solve this question using something which is known as the Thevenin's theorem, which you will study in the first or maybe the second semester or maybe the third semester of your engineering.
Okay, sir.
Is the point clear to everyone?
Yes, sir.
Akka?
Pakka.
Have you noted this down?
Yes, sir.
Please note this down because you will not find this in any books. Please note this down because the books that you will refer are only undergraduate ones. And this is from an engineering college ka book because this concept is from an engineering college, first year or second year. So note this down. And if a question comes, not many people would be knowing this. So you would have an edge. So pray to God that this question comes in your exam. Once you are done, please let me know that you are done. Noted it down, bacha?
Yes, sir.
Then we come to this famous question. I guess you have solved this question. You have found out the equivalent resistance between point A and B. Yes or no?
Yes, sir.
And I hope you know how to do this, right? But this is not to find out the equivalent resistance. This is fine. This is you have to find the ratio of R2 by R1. Consider an infinite ladder of network as shown. A voltage is applied across points A and B. If the voltage is halved after each section, find the ratio of R2, the vertical resistance, divided by the horizontal one. Can you do this? We have done a similar question. That is the hint. Shall I do it for you, bacha?
So one. One, sir.
R2 by R1 is 1.
Yes, sir.
The answer is 2. How did you get it? So, as you can see, the voltage across this is V, and the voltage between these 2 points is V by 2. Yes or no?
Yes, sir.
Voltage across R2, this resistor will be V by 2. Yes or no?
Yes, sir.
Then the voltage across R1, see these 2 points is V. If I apply Kirchhoff's loop law, I will get the voltage across R1 as V by 2. Yes or no?
Yes, sir.
Okay. Now, if I say the current in this branch is I, what when the voltage is halved, the current will also be halved. R2, the current in R2 will be half that of current in R1. Do we understand this?
Yes, sir.
Because the voltage has been halved. The voltage has been halved, the current has to become half. But between this point and this point, the voltage drop is V by 2. Between this point and this point, the voltage drop is V by 2. So R1 into I will be equal to R2 into I by 2. From there, you will get R2 by R1 as 2 ohms. Do we understand this?
Yes, sir.
Okay. Was it a tricky question?
Yes, sir.
So we have done it now. So when it comes in the examination hall, you should not be tricked. This is a question which I will give you as homework. We will discuss it in the next class. It's a simple one. These are the type of questions that are more bound to come. In the given circuit, find the current in the wire between the points A and B. A and B are connected to each other with a wire which does not have any resistance. To find out the resistance between the points A and B. Do you understand the question? Have you noted down the question? Battery
Yes, sir.
voltage is 32 volt. One resistor is 1 ohm, then 2 ohm, then 2 ohm, then 1 ohm. To find the current in the wire AB and in which direction it flows, whether it flows from A to B or it flows from B to A. That is what we are looking at. So, in the time for today's class is over. So, I'll wind up today's class here. We have done some good problems in current electricity. We'll wind up the chapter in the next class probably. Uh, with some more problem on circuits and problems which are not from circuit but a part of current. We'll do that. Do you want me to do RC circuits as well?
Yes, sir.
Okay, so we will try to start with RC circuit. Let's see if we can complete RC circuits in tomorrow's class. Because one question will come whether it will be from current or RC or C. There has to be one question in the exam which will come from there. So let us log that question away. So I'll say good night to you all for today's class. I hope you get the sheets. Ask the office people to give you the sheets. Okay. Chalo then. If you have any doubts, you can ask me. Else, take care. I'll see you tomorrow.